Thanks everyone so much for joining today. Hope everyone's staying safe and staying healthy and staying active wherever you are. We're going to take a look at a pretty extensible and sort of recyclable pattern that we see here in the space of enterprise blockchain and surround data marketplaces. Surround this, the semantics of sharing data, allowing people to potentially purchase data using token economics with Ethereum. But the important thing is where that data is actually stored, right? How it's referenced on the blockchain and where the private and sensitive pieces are stored. And we'll look at a couple different approaches using services that Kaleido has baked into the platform. So a couple slides for me, a few pieces of admin, and then we'll dive right into it. And I'll do my best to keep this to about 30 minutes today. So at super high level, Kaleido, we're built for modern business networks, completely industry and use case agnostic. So this could be healthcare, this could be insurance, this could be pharmaceuticals, supply chain, et cetera. We'll see when we take a look at the platform, not only in terms of the UI and the UX, but the underlying APIs. It's really exceedingly simple to use and to program against. Every service that we have is backed by a REST API, and we've even done a lot of things to make it easier to speak to your smart contracts without becoming a Web3 JavaScript expert and having to use thick SDKs or client libraries. And then the last piece, we have tons of components and sort of out-of-the-box functionality that just makes Kaleido ready for the enterprise, whether it's key management, whether it's high availability, DR, auto-scaling, or different levels or t-shirt sizes for the performance that you need. So you get all that out of the box in Kaleido. And our goal really is just to make it really shallow, sort of flatten the mountain as you're wrapping your head around this new technology, hopefully standing up a pilot, doing some interesting stuff, and then getting into production. So we try to give you those logical stepping stones and building blocks so that you actually can get a production solution running and have some quantifiable value, add some value to your industry. We'll touch on this super briefly, and then we'll hop into the product. But this will be personified today in the demo. The blockchain itself, those nodes and those smart contracts and the algorithm, the mining of the blocks, it's really important. But when you take a step back and look at all the different components that go into a proper solution, you see that the chain really is, maybe only 5, 10 to 15%. And you start visualizing it as a proper full stack application. You need a lot of answers around data. Where is data stored? How do we integrate with our private off-chain data? What's kept on-chain? What's kept off-chain? We'll really harp on this today, this bottom layer here. At the transactional layer, there's certain blockchain transactions that can't be public. We can't use GEP and proof of authority for everything. We might need to use Quorum or Besu along with Istanbul BFT and do private transactions. Specifically important, and we'll touch on this again today as well, is the consumption of those state changes, right? If someone invokes a smart contract and writes a potentially interesting piece of information onto the blockchain, you don't want to need to be querying or do WebSocket polling, for all of those. You want to be able to reliably consume those state changes and just ingest events into your application tier and ultimately into an off-chain database. So we have a wonderful feature that makes it very easy to do this without building your own custom infrastructure, without building your own, guaranteed delivery pipes. Middleware, we're not going to touch on this a ton today, but obviously a really important piece. We've done a lot of work on application-to-application messaging, oracles for those data feeds, and connectors and integrations to your hardened, expensive, pre-existing back office systems. And then lastly, at the app layer, the fun layer that everyone really likes here, we'll touch on some tokenization. We're not going to go into bleeding edge crypto, but we do have some zero knowledge proofs in the platform. And then we'll take a peek at how we've made it easy to build your applications and not have to, saturate or overbear them with a really thick or heavy client library. So that'll be the heart of the demo today. And like I said, it's around a data marketplace. It's around sharing data, exchanging data, and potentially weaving some token economics into it. So I'm going to point out 2 core services that we're going to look at today. It's our document exchange, our document storage and exchange service, and then our event stream service. This is the really important one. I'm going to spend a little bit of time on this, I'm not going to go ad nauseum, but we'll look at the details at sort of a high level. So what we've built here is the ability to integrate with your existing private data stores. So if you have private data that's in an S3 bucket or in a Microsoft Azure Blob container, you can very seamlessly integrate that with a Kaleido service that we call our document store service. Now, this is really important. Kaleido is not going to persist that data. What we're going to do is we're going to mirror the existence of that data. And more importantly, we are going to give you the transport infrastructure. We're going to give you the rails to securely exchange that data with other counterparts inside of your business network. So maybe this is healthcare certifications, right? Maybe this is a fire compliant JSON file. Maybe this is educational certifications. Maybe this is legal or real estate titles, pharmaceutical trials. Just use your imagination and think about what is sensitive, what is private, what might need to actually be paid for. And you can choose to exchange that data with other folks inside of your business network. Now, this is best of breed asymmetric encryption that's happening here inside of this transport layer. And I'll explain it at a very high level. And if we do have crypto experts in the audience and you're more interested sort of in the construction and the sharding and the enveloping and the sign verify logic, we have some documentation with about 66 bullet points explaining exactly what happens under the covers. But we can think of each document store service as having one or more inboxes, one or more mailboxes. And in Kaleido, we call those destinations, right? So just think of it as an email inbox. Each destination has accompanying crypto material. Namely, there's an X509 certificate. So let's think of a scenario here where client A or org A, healthcare institute A, wants to send some private data to healthcare institute B. Maybe these are insurance carriers, maybe these are hospitals, maybe these are legal entities, law firms. Again, use your imagination. So what's going to happen is that data is going to get hashed. It's going to get signed. It's going to get encrypted by the counterpart's public certificate. And then it's going to get compressed. It's going to get sharded. It's going to get enveloped. And then those chunks or those shards are going to get transported via a Kafka transport layer under the covers. And then the recipient, the only person in possession of the corresponding private key for his destination certificate, is going to be able to decrypt that data. They're going to be able to verify the signature from the sender. And then they're going to actually perform the exact same action here. They're going to take an acknowledgement. They're going to let the sender know that that delivery was successful. And they're going to do the same flow of asymmetric encryption. They're going to take member A's destination certificate, public certificate, and they're going to encrypt a payload saying, yes, we've gotten this. And now client A is going to have an acknowledgement with this signature that the document was successfully received. And this is important. Those acknowledgements are stored in your document exchange instance on Kaleido, but those can also be referenced on the blockchain for increased indelibility and increased proof that that document was actually exchanged. Really, really powerful feature here. And like I said, extensible to healthcare, construction, you name it, any scenario where the data is marginally sensitive or fully sensitive and private, but does need to get securely exchanged inside of the network. And this will potentially make a lot more sense when we look at it in practice or in action. And then the other one is our event stream service. And this may be a little easier to kind of wrap your head around. But essentially what happens here is inside of a smart contract, there's an events interface that you can code to. And then you can have certain methods or certain functions, and you can choose to emit that event when that method is invoked. All you have to do in Kaleido is you just need to teach Kaleido about where you want those events to be delivered. Teach Kaleido about an API endpoint, a webhook, and Kaleido, again, using this Kafka infrastructure that we have under the covers for our transaction submission and for our app-to-app messaging and our document exchange. Well, we use it again here with our event streams. And we're going to give you reliable real-time notification of any of those state changes inside of the network. And this is a really awesome feature here. So say, for example, you've been working on Kaleido and you have a heavy Web3 server application, and you've already instantiated your smart contract, and you've already invoked a lot of transactions. You can still leverage this service here. All you need to do is teach Kaleido about the ABI of your smart contracts. Teach Kaleido about those interfaces, and then Kaleido will auto-detect all of the event signatures that are inside of that smart contract. And what you can do is you can go back and you can get every historical event that has taken place inside of that smart contract. And the value here is that you're not going to the chain layer to do queries. That's not really efficient. what you're ultimately going to have is now you're going to have, you know, an underlying database sitting right next to your application that A, is going to give you rich, efficient queries, but B, and perhaps more interestingly, now you can start automating, optimizing your own downstream business processes, right? So a new piece of data is made available, or someone asks for a bid on a security. Again, we're just using our imagination here about all the things that are possible. But the idea is that you're now optimizing your application tier, and thanks to Kafka and this automatic retry and, you know, idempotency and guaranteed delivery, you're getting all of those state changes, you're getting all of those historical events. So this is, you know, this works out of the box if you just kind of use our Kaleido REST API gateway to upload a smart contract, and that's how you're developing your application. Or, like I said, if you already have a hardened baked application, you've been running transactions for months or maybe even a year, you can just teach Kaleido, again, about the ABI, and then Kaleido will say, hey, here's all the signatures, just grab and choose, you know, the events for whichever ones that you care about. And I'll show you guys how easy this is here in a second. So those are the two core features, excuse me. We'll also look at IPFS here at the end, and a couple other ancillary features inside of the platform. So let's just go ahead and hop into it. One final piece of admin, all of these have been recorded. We've been doing these for about 8 months now. So every single piece of functionality in Kaleido has had a Tech Tuesday devoted to it. And we've had a few of our SMEs in-house that have kind of talked about some really cool bleeding edge stuff. For example, Jim, our protocol expert, last week he talked you through upgradable contracts and proxy smart contracts. So that would be an interesting one for folks to perhaps go back and look at. So just YouTube, Kaleido Blockchain, click on the videos tab, and then boom, they're all curated there for you over the course of 8 months. Last thing, if you guys do have any questions, feel free to use the chat or the Q&A, and I'll get to them intermittently throughout this demo. So let's go ahead and do it and take a quick look at events. Then we'll look at our private data marketplace, and then I'll show you kind of a public version of a data marketplace where we use IPFS and everyone's automatically notified about the fact that, you know, there's new data and they can all download it because they're running an IPFS node. The first version here with the data marketplace, this is going to be kind of the more sensitive enterprise grade private variant. So the first thing we want to do is we want to look at the event streams functionality. And what I've done here up at my business network layer, at my consortium layer, is I've created what we call a contract project. And this is how Kaleido basically can build you a RESTful interface for all of your smart contract methods. You can either just tell Kaleido to go out to this GitHub URL and compile this source. You can teach Kaleido about the bytecode and the interface, or you can just upload some Solidity locally from your machine, and Kaleido will compile it for you. So lots of different versions. We try to make it as easy as possible for you to get these interfaces and for you to not have to use a Web3 library. If that's the route you want to go, we're not stopping you. We're just trying to make life easy for folks that, you know, didn't roll out of bed and just, you know, have Solidity expertise and all of these APIs in their back pocket. So I compiled this code. It's simple storage. It's really not very interesting. It has, you know, a single global variable that's a positive integer, and then it just has an event called data stored that emits the argument, emits the unsigned integer when we invoke the method, the set method. So here we see we have a set, a get, and a query. These are redundant. They do the exact same thing. But what we see here is when we invoke the set method, keeping our unsigned integer under 100, we're going to emit that event that we defined right up there. And so what I'll do is I'll go ahead and, you know, teach Kaleido about some endpoint. I'll tell Kaleido that this is the event that I care about. This is the signature. And every time I invoke the set method, I'm going to get a reliably delivered JSON payload to that endpoint. So again, I've already compiled this right here. There's the ABI, there's the bytecode, and now I can promote it. Basically, I can promote these APIs into one or more environments. And we've built this smart contract management feature to go hand in hand with the DevOps pipes that everyone is already comfortable with, right? You're gonna have some sort of sandbox or staging. You're gonna have some sort of UAT or pre-prod, and then ultimately you're gonna have some sort of production. So what we let you do is just create these projects, create compilations. If they fail, you can just delete them. But then ultimately what you can do is you can just logically promote those APIs into your dev, into your UAT. And when your application tier is hardened, all you do is change one little endpoint in your application and you're good to go. No logic changes. So now I'm building a name for the APIs. I'm just going to call it SS, shorthand for simple storage. And now we can go ahead and view that API. So I'm viewing these REST APIs through a container on one of my nodes that's sitting right next to the node. So I'm going to look at node number one. Let me go back a second. Oh, sorry for this. So I have a Geth POA environment. I just have two nodes hanging out inside of it. Nothing really exciting. So back to apps and integrations, back to my gateway APIs. And again, now I'm going to view that API through node number one here. So I haven't deployed it. This is just a definition of those methods that we looked at inside of the smart contract. So we see here that it's looking for this address route, right? It wants to know where to point on the blockchain to do stuff with these methods. We don't have that yet. So we need to call the root post method here, and we need to instantiate it with an integer. So I'm going to click try it out. And again, this is just REST APIs that, of course, you would program against. You wouldn't be using the Kaleido Swagger interface here to do this, but we give it for you out of the box just to get comfortable with it. It's going to use the node's default Ethereum account to sign it. And then it's going to auto detect under the covers. It's going to do all that gas estimation. It's going to do all of that nonce management, sequencing, RLP encoding, all the gnarly things in Ethereum that we don't want you to have to concern yourself with. Again, if you're comfortable with it, go for it. But this is just kind of like the easy button where you don't have to become an expert. And rather than dealing with hexadecimal, we'll let you have a human readable name on your smart contract. So I'm instantiating this guy. We're going to call it, SS123. We call that an instance inside of Kaleido. And it's going to have an initial world state of 99 for that variable right there. So boom, we see that it was a transaction success. And now we can go back here and what we'll see, I'm going to click this API tab, the gateway API. We'll see that I've created an instance of it now. I've brought these APIs to life, and I can create as many instances as I want. So if this is extensible or recyclable business logic, if we wanted to have a smart contract for different geographies, for example, or if the key value pairs are the same and we just want to separate it or compartmentalize it through different departments, we can do that. And then we can just use this naming convention to sort of identify it very, very clearly for the rest of the network. Okay, so there's the instantiated smart contract. Now what we want to do is we want to create an event stream. We want to use that signature, that data stored event, and we want to create an event for it. So I'm going to have it emitted through node number one. I'm going to use this little dummy subdomain site called request catcher, really convenient for trying out. In the real world here, what you would typically use is like a Lambda function fronted by an API gateway with some, a nice token in front of it for security. I'm just going to do this out in the wild here for convenience sake. So we're creating a name for that event stream. Now we need to teach Kaleido about the endpoint, about the API where we want it delivered. I'll just create one called SS123 right here. And I'm going to teach Kaleido about this endpoint right here. Again, this would typically be an API gateway where you're sending it to. You can choose your batch size, your timeouts, your blocked retry, and again, best practice, please put like a bearer token in front of this. You don't want that to be sort of hanging out in the public internet. So click finish. So now we've created our event stream, and now what we want to do is we want to create one or more subscriptions encapsulated inside of this. So I'm going to go down here to the subscription. I'm going to create one called data stored. And bear with me, I'm doing this because our other smart contract for the private data marketplace, it's much more interesting and it has a lot of events. And so what we're going to do is we're going to go look at all those events, but I want everyone to have some context of sort of, what the purpose is here. Okay, so now we're going to select an API gateway. And this was my point of if you had gone the Web3 route and taken the classical Ethereum approach of instantiating your smart contract, all you would have to do right here, Kaleido is going to say, hey, you don't have any gateway APIs. And we're going to give you all of those different routes to either link to GitHub or supply raw source and bytecode and ABI, or to upload some Solidity from your machine. And we'll make it real easy for you to create a gateway API so that you can then subscribe to those events. So obviously I already had one that I called SS, and now Kaleido is going to auto detect that signature inside of it, the data stored. So I'm just going to take it from the latest because we haven't actually invoked the set method yet, and I only have one instance of it. So if you have multiple instances of that API, of that event, you can choose to say, hey, I only want it for this smart contract, or I want all the events that match that signature, completely customizable to your use case, to your application here. So go ahead and click finish. We're good to go. And now what we want to do is we want to actually invoke that set method so the data stored event is emitted. So I'll go back to the dashboard. I'll go down to my apps and integrations. I'll click on my gateway APIs. I'll click on this guy and we'll open him up and we'll go ahead and view him through node number 1 again. So now what we see here is we see that our endpoint has changed. This is not a gateway API endpoint. This is actually an instance. And since I gave it a friendly name, we don't see a hexadecimal smart contract address here anymore. We actually see that human readable prose or pointer that I put in there. So we can do a quick get. We'll see 99 back. If we do that, that's what we instantiated it with. That's what we passed to the constructor. Boom, there's 99. And now if we go ahead and call that set method right there, right, the one that's coded to emit data stored, over here on my request catcher, I'm going to get a JSON payload. That's not terribly interesting, but it's going to tell me some stuff about the transaction hash. It's going to tell me the argument that I upserted here for our global variable. What's the date? 6th. So I'll do 6 right there. We're good to go. Again, it's going to auto detect the signing address for us right there using the default account. I'm going to submit it synchronously, so it's going to poll or wait for the transaction to be mined. And this is get POA, so between 3 and 5 seconds, typically, we'll see that full transaction receipt returned right there. So it took a little longer. And then over here, inside of, again, think more along sides of like Lambda function API gateway. But here we see the interesting things from that transaction, the block number, the index, transaction hash, and then we're going to see the argument that I passed to it, right? This is the event that we coded it to emit. And you can do more interesting things with your events. For example, like adding message.sender in there so you can actually see who invoked the smart contract. It's a pretty common one, and that could be quite useful for, folks want to know who's actually, submitting this data and making these state changes. So again, completely customizable based on your requirements. Okay, so there's the events. Let's press forward and actually do some more interesting stuff now. Okay, I'm going to switch accounts, and I'm going to go to our demos account. And we're going to look at our private data marketplace account here. So this has a bit more going on here. So what we have is we have 3 nodes mimicking 3 different organizations inside of the business network. And each of these nodes has a document store service, org1, org2, and org3. And this is where, those documents are either going to be persisted in a Kaleido container, or they're going to be integrated with an off-chain container, for example. This one, for example, is integrated with AWS. I was messing around doing some funky things this morning, so I created a bunch of failed transactions, but rest assured, this should work as expected. So that's what we have here. We have those 3 nodes, and we have the 3 document store instances within the network. Now what we have is we have 3 different dApps. We have 3 decentralized applications for org number 1, org number 2, and org number 3. And what we're going to do here is we're going to publish some data. We're going to publish some pharmaceutical trials. We're going to publish some healthcare provider records. We're going to publish some carrier information, anything that makes sense, construction information, anything that makes sense sort of inside of your business use case. And these applications, these have a Mongo database sitting underneath them. So anytime anything interesting happens on the blockchain, they're consuming that event and they're persisting their underlying database with all of that information. So in other words, these dApps are a one-to-one reflection of everything that's been written into the smart contract here. Inside of the smart contract, like I said, it's quite a bit more interesting, and there are a lot more event streams. So we see that there's 1, 2, 3, 4, 5 subscriptions for each node inside of here. So we'll take a look at a couple of them, but essentially what we're doing is we're publishing data, we're purchasing data, we're rating data, and then we're confirming the receipt of data. Those are the main events that we really care about here. So we can click on this one, go down and look at the signature. This is for delivery confirmed right there, okay? This is what we're gonna say, like after we got that acknowledgement back from the recipient, we're then gonna invoke the smart contract and prove that it was confirmed with their signature. We can go back and we can look at, the fact that something was published or purchased or rated. And this is what's going to update our dApps, all of these applications for every participant in real time. So these are the interesting events that we care about. So the first thing we'll do is we'll actually publish some data. So I'm going to use org number 1. Again, use your imagination, whether these are healthcare providers or law firms or supply chain. I'm going to publish some dummy private data here as org number 1. And what we'll see, since we have that published event and every node is subscribed to it, as soon as I publish it and invoke that smart contract, all of the other 2 applications or dApps, they're going to get that event stream and they're going to be able to update in real time. So you can build out your dApp as I guess extensively as you like. The way this one is built is we have a few pieces of metadata, kind of like a key value pair that's going to go alongside a hash of our private document. And that's what gets invoked under the smart contract. That's what gets written to the blockchain. So I'm going to use an ID of 42. I'm going to call this example private data 42. And this is not going to be interesting stuff. This is just a little text file that I created here a few minutes ago. But you could have information about timestamps, about signatories, contingencies, certifications, regulations, penalties, again, or it could just be classic, provider information or certifications. So I'm going to open this, and what's going to happen is this is going to get uploaded into my document store instance. It's going to get hashed, and then it's going to get written to the blockchain along with those 2 pieces of metadata. So if I didn't screw anything up with all of the underlying infrastructure here, what we should see is a transaction that comes in. And pretty vanilla transaction, like I said, right? Just has the hash and it has that metadata. But more interestingly is the event that gets emitted to both of these other dApps right here. So now they know that there's new data that's been published. They know that org number 1, added some new data about potentially, a doctor that they need information about. And this is where sort of, the efficacy of your network comes in. If you are consistently purchasing information, from one of the orgs inside of your consortium or your business network, and you trust them, then you're perhaps a lot more interested when they publish data. And we extend this by allowing you to rate the data too after you purchase it. So here we see that those events were emitted. They both know about this. And now, acting as org number 2, what I can do is purchase this data. So we're going to weave in the classic Ethereum construct of ERC20 tokens, and we're going to exchange some tokens, and then that's going to trigger a document store transfer. And then this org, after they receive the document, is going to do that opposite flow and acknowledge receipt of the document, and then that receipt or that delivery confirmation is going to be written to the blockchain. So we're going to see 2 smart contract invocations here, the token transfer and then the delivery confirmation emitted by this guy and consumed by org number 1. So this will cost 10 tokens. So we should see that decrement to 360 and this increment to 1940. And then when we go back to the block explorer, we should see 2 transactions. Again, hoping I didn't actually screw anything up with all the configurations and all of the endpoints here. So there's our token transfer right there. And now after that document is exchanged and that receipt is sent back to org number 1, we should see a 3rd transaction come in, delivery confirmed. And lastly, what we can do is we can actually rate that data, and we'll be able to see in real time here for org number 3, we'll actually see this rating pop up. I'll give it a 5-star rating since it was good data. Of course, we could download this data if we wanted to right here. It's going to be that really uninteresting payload that we just looked at right there. But that, of course, is the point of consuming or taking data in. You're going to want to download it, look at it in some capacity. So I'll go ahead and rate it. We'll give it 5 stars. Again, this is going to be our 4th invocation, our 4th smart contract transaction here. And as soon as that transaction is mined, we see this updated to 5 stars. So let me move the Zoom bar super quickly. And now we can go back into our Kaleido console, and we can go into our document store instances here, and we should see notification of successful transactions. So again, these are a few that I was screwing around with, so those didn't work. But we see that we have a status of received, and potentially more interesting, what we have is we have those acknowledgements right here, right? We have the recipient signature, we have the sender signature. So we're able to write additional proofs of this transaction and of this successful transfer onto the blockchain. So like I said, this is just sort of a second layer of proof and indelibility here, in addition to those token economics that we've woven in. So 360 and 1940 here. And this is not a binary thing. This is not one size fits all. You can start getting really creative, and you can make, you know, different pieces of data potentially cost different amounts or different allocations of tokens, right? You could have a network operator who's minting tokens and who's allocating those tokens to the rest of the network. You know, maybe they could be in charge of the on-rails and the off-rails, burning tokens if you want to exchange them for fiat, potentially. Lots of different creative things that you can do using this data transfer and data exchange and weaving in token economics as well. Okay, let me spend like 5 more minutes, and then I'll try to give everyone 20 minutes back here. So the last thing I want to point out is you can create these same constructs, but you can do it in maybe a bit more of a public manner. In Kaleido, everything's authenticated, firewalled, permissioned, so we know exactly who we're dealing with. We know every participant inside of our business network, but maybe the data should be accessible and should be shared amongst everyone. Maybe we don't need token economics, or maybe we don't need it to be kept in an off-chain private data utility. And that's where IPFS can potentially become a bit more interesting. You know, with IPFS, it's a shared cluster, peer-to-peer file sharing. So as long as you know the hash of a document, you're going to be able to download that document. If it's symmetrically encrypted, then of course you're going to need the key. But in the scenario we're going to show here, I'm just going to show a flavor of, you know, sort of public IPFS. Okay, so I'm going to log out again, and I'm going to go back into that original business network that I created for simple storage and event streams. So this is going to use, again, our REST API gateway for easy transaction submission. And then it's going to use IPFS nodes for the storage. This actually doesn't use event streams, believe it or not. These are going to be queries into IPFS once the smart contract basically has the hash written to it. And then any state changes that happen, the DApp is actually going to go to the smart contract for those on this. So what I've done is I've created another smart contract project called Document Manager. And what we're going to do is, just like simple storage, we're going to go ahead and instantiate this inside of our environment, and then we're going to register an entity. We're going to basically bind the private key on node number 1 to an organization or an entity inside of the business network. So here's that compilation, and just like with simple storage, we're going to promote it to an environment. I'll call this DM123. And now we can, just like with simple storage, again, we'll view the gateway API. This one does not need an argument to the constructor right here. We just need to instantiate it. And just like with simple storage, I'm going to actually give it a human-friendly name. So DM123 for that guy. So this will bring it to life. And now we need to register an author of documents. Basically, we need to, like I said, we need to bind the private key on node number 1 to a single entity inside of this business network. So I'll go back to the Gateway API. We see that we've created an instance of it now. And what I will do is I will invoke this. And let's say I'm going to be like a healthcare or a health inspection agency, FDA or food safety. The example I have is uploading pictures of chocolate chip cookies and associated ingredients. So that'll be the author for this example here. So we're going to go ahead and call this register author method right here. Click try it out. Again, everything that I'm doing here would be done programmatically. Just get a little Swagger client and use your favorite programming language. Call this health inspection agency, and just go ahead and invoke it. Again, we're good. We have the default account there, and we can just go ahead and execute this synchronously. So 3 to 5 seconds, we'll get that transaction receipt back, transaction success. So now we can close this. We can do a get, or not a get, we want to call get author name, and this will show us back the healthcare or whatever the heck I just named that guy. So again, we're binding that private key on node number 1 to this arbitrary string or this arbitrary name. So we want to go ahead and put that default Ethereum account in there. And then this should give us back the name that we just put in, Health Inspection Agency. Last thing we want to do is we want to go ahead and populate our other DApp with some of these strings that we have here. So, oops. So I have this DApp open in my other window called our Kaleido document client app. And the first thing we need is we need this gateway API URL right here. We need the actual shorthand for the instance. So that's this up here at the top. So I'm going to go ahead and copy that. Where the heck did it go? Here it is. Just bear with me. HTTPS. Give it that string. Now we need the endpoint for our IPFS node, which we can grab right here. Dashboard. Here is our IPFS node. So just click manage. So we want this API endpoint. We have our name, Health Inspection Agency, and then we need security credentials for everything in Kaleido, whether it's a node, whether it's a IPFS node or a blockchain node or a document exchange instance. Everything has boundary security. So we use these strongly generated app credentials to give us that secure TLS connection. So I'm going to go to my apps and integrations, and I'm just going to make a quick set of app credentials. Doc manager, click create. And first we want the ID, and then we want the password. And if I put everything in right, this should connect into our blockchain. Okay, so everything worked there. It says we have no documents to show. And the idea here is we're going to just start uploading documents. One thing we've done here is we've created relationship mapping with documents. So what I'll show is I'll show the cookie, the chocolate chip cookie, and then we can create relationships to, butter, sugar, vanilla, chocolate chips. Maybe marry that to a real world example. Maybe we have a construction project and we, have a finished piece of real estate. Well, we might want to marry that existence or that document with inspections and with certifications and with the sourcing of the materials, for example. Again, this is completely customizable. All of these dApps are customizable based off of your industry, based off of your vertical. So first, we're going to add our chocolate chip cookie, whatever the heck it is, cookie JPEG. And it has no references, so I'm going to go ahead and submit this. And again, this is IPFS, so this is basically invoking our smart contract with a hash. Oh, I did something wrong. Maybe I'll try it again. If this doesn't, okay, so I've misconfigured something. Forgive me. We were going too well there for 40 minutes, but pretty standard with a live demo for one or two things to potentially go wrong. But taking a step back or fast forwarding here, I guess the idea here with using IPFS versus document store is that this data is going to be shared. It's going to be accessible to the entire network and to everyone that's running an instance of this dApp right here. And then the other thing you can do is you can start creating references. You can start creating relationships, maybe with like a macro document or a parent document, and you can have child documents or subsidiaries referenced by it. So apologies that I screwed something up there. Not entirely positive what I did, but tried to do it from scratch, which is never the greatest idea. So that'll about do it, I think, for today. If you guys are interested in further discussions around anything technical or commercial, or if you want to discuss your use case in more detail, you can feel free to reach out to us. I'm going to share my email directly in the chat, but you can also reach us, within the support modal inside of the console right here, just the question mark, contact us, or you can reach us at sales@kaleido.io or support@kaleido.io as well. So thanks so much, everyone, for attending today. Again, hope everyone's staying safe, staying healthy out there, And feel free to sign up for Kaleido and give it a spin. It's free to sign up, and you get 60 days on our starter plan to experiment and tinker with all the resources and sort of create yourself a preliminary POC before you transition into that pilot and hopefully into that production phase of your project. So thanks again, everyone, for sharing. This is recorded and it will be shared, and we'll email you the recording as well. So thanks, and have yourselves a great remainder of your Tuesday.